Plastic was initially defined as flexible and easily formed. It was only recently given the name polymers for a type of material. This material is composed of long chains of molecules. Polymers are abundant in the natural world. Cellulose, the component of plant cell walls, is a ubiquitous natural polymer. To reduce plastic manufacturing worldwide, corporations are increasingly looking to nature for organic, sustainable alternatives. Innovators are demonstrating that solutions are readily available, and our reliance on plastics derived from petroleum may soon end. In the past century and a half, humanity has discovered how to produce synthetic polymers, sometimes using natural materials such as cellulose, but more frequently using the abundant carbon atoms provided by petroleum and other fossil fuels. The world has struggled to solve the hazard of the non-degradability of this material. But what if you know that the solution to the plastic epidemic might be as easy and green as seaweed? So the question is, could algae replace plastic in the future? Let's see if the future of plastic lies in seaweed. Let's dive in without wasting any more time. Plastic trash is undoubtedly a significant problem for the oceans and marine life. The Ocean Conservancy reports that a truckload of plastic waste enters the ocean every minute, every day, all year. Even the most distant, untamed beaches are now inundated with plastic garbage, and enormous, swirling plastic gyres have been identified in the world's major oceans. A recent article published on Science Direct indicates that the economic costs of marine ecosystem services lost due to plastic pollution could reach $2.49 trillion annually. Our consumerist civilization is supported by sturdy plastic pillars. However, these columns rapidly sink toward a liquid base, the ocean. The Great Pacific Garbage Patch is one of many sites where plastic may be found. Microplastics were discovered on the summit of Mount Everest, the highest point on Earth, and the Mariana Trench, the deepest point in the ocean. If that isn't concerning enough, scientists discovered them in human blood for the first time earlier this year. This is no good news, and if you are worried, you have every right to be. As these microscopic plastic particles travel through our blood, experts speculate that they may reach essential organs and impair their function. While awaiting the suspected disturbing response to this inquiry, you may ask why plastics are not being recycled. The answer to this question is tricky because it relies on the plastic in question. Unfortunately, it is not economical to recycle the majority of the plastic that we create. Not even China, which in 2018 permanently broke the useless plastic recycling loop. So, what do we do? According to years of study, microbes can be fed plastic as an option. Relieving news, right? Researchers have spent days building a plastic buffet without rest. But how does this work? They have discovered a microorganism that loves to feed on polyethylene terephthalate. They can readily separate it into its components, ethylene glycol and terephthalate. However, the decomposed components must have a practical application for this process to make sense. While EG has been used as an antifreeze for automobiles for years, TPA was useless until a few months ago. Scientists then discovered the recipe for a TPA-hungry enzyme that degrades TPA. This enzyme research is gradually leading to commercialization. Carbios, a French company, is expanding its enzymatic PET to recycling process. Carbios formed a partnership with Indorama Ventures last February to build the world's first industrial-scale PET biorecycling plant after demonstrating their innovation on a pilot scale. Each year, their enzymes will consume 2 billion PET bottles. They claim their technology can repeatedly upcycle PET components into high-quality, 100% recyclable new PET products. With a 12% decrease in energy use and a 90% reduction in carbon footprint, their enzymatic PET recycling process output has increased over time. This is where Seaweed, another plastic-free response, comes into play. There are two primary reasons why seaweed could be a viable replacement for plastic. For starters, its sourcing is more environmentally friendly. Compared to terrestrial plants, seaweed grows 10 times faster, uses less water, and occupies less than 10% of the land required by those crops. Converting land-based plants into plastic-free utensils will also impact food production. Instead, seaweed will not endanger food security. Aside from sustainability, there is a practical aspect to consider. Seaweed contains an oily substance fraction that may function similarly to petroleum-derived oil. A slew of startups have recognized seaweed's potential and are now attempting to ride its slimy wave. Yulu has begun converting seaweed into biopolymers after raising $1.3 million in September, specifically polyhydroxyalkanoates. Aside from the amusing names, the Australian startup claims their materials are as strong as plastic and biodegradable even in the deepest and coldest parts of the ocean. According to studies, PHAs fully degrade in about 2 months under standard conditions. This is a significant improvement over traditional plastic, which can last for centuries in the worst-case scenario. Yulu is collecting seaweed from an Indonesian farm with the support of the Commonwealth Scientific and Industrial Research Organization. The harvested seaweed is first whittled down into biobricks, including sugars, which are then extracted and tossed into a microbe-filled tank to ferment. Making PHAs from seaweed-derived sugars would be more environmentally friendly than corn-based glucose, the typical feedstock used, because corn is a water-intensive crop that takes up a lot of land. Yulu, on the other hand, only requires seawater and microbes. Furthermore, their material would be carbon negative because seaweed absorbs CO2 while growing in the ocean. PHAs could be used in a variety of packaging materials, including films, boxes, and foams. The good news is that we may see the Yulu product soon, as the startup plans to open its first pilot plant in 2023. While Yulu seaweed-based products are just getting started, Noplas is already riding the wave. The UK-based startup provided edible seaweed pouches filled with an energy drink for the London Marathon in 2019. Their Ruho capsules quenched the thirst of over 40,000 runners while saving 200,000 single-use plastic bottles from ending up in a landfill. But it's not just about water. Nopla is attempting to make packaging literally disappear. What is their special sauce? Their research team created a machine that combines brown seaweed with other plants and produces tasty membranes. You don't have to eat a membrane, as delicious as it sounds, but you could. They'll be gone in less than 6 weeks in your backyard composter or anywhere else. Aside from pouches, Nopla developed a plastic-free takeaway box liner. This satisfied Just Eat, which tested and possibly tasted 30,000 biodegradable to-go food containers across the UK in 2021 alone. Nopla's $13.5 million, raised in December 2021, will allow their boxes to deliver food to people in other European countries. With the various ongoing studies and investigations, seaweed may likely solve the world's plastic degradation problem. That's it on seaweed, the future of plastic. What are your thoughts? Do you think seaweed will make the whole world safe? Or are scientists simply chasing clouds with this novel idea? Let us know your thoughts and considerations in the comment section below. If this video is insightful, please go on and like this video. Remember to subscribe to our channel and click the notification bell for more updates.